Good evening once again. Today we are now planning to continue with our topic on rotation. And let me share my screen. Just give me a moment. Okay, so we are starting with once again on the misconceptions in physics. Now, as usual, we are continuing with the chapter on rotation, wherein we are discussing about torque, moment of inertia, and angular quantities, which would be useful for those who are looking at the advanced physics or maybe JE mains or JE rotation, JE advanced, right? And if you want to note down for all other videos, you can visit my website, which is available here. So far, I think around 96 videos have been done. Okay. Now let us look at this question. Now the question says, a light rod of length. Okay, let me take up my pen initially. It's a new laptop, new software, so every time I need to select it. Okay. So a light rod of length 1 meter is pivoted. Where is my cursor? Is pivoted at its center and two masses M and 2M are hung. Just a moment. I'm not able to see my cursor. Right. Okay. So, and 2M are hung from its ends as shown in the figure. The system rotates with an angular acceleration of alpha 1. And if the mass of the rod is also m kg, then how will the angular acceleration differ? So initially what he does is he does an experiment with taking a light rod over here and attaching two masses, 2m and m here. Now what do you think the rod will do, the system will do? The system will now start rotating like this. Why should it rotate like this? Because you see, there's a force 2mg acting here. There's a force mg acting here. And you see, this force is larger than this force. And hence this object should now, this mass should pull this rod like this. So this will now go upwards like this. So after some time, you will observe that this rod will become like this over here. So with the mass m attached over here and the mass 2m which has been attached over here. This is what will happen. Okay. Now he is asking you to find out the angular acceleration alpha 1. You need not do it, but if the mass of the rod is also m kg. Now next what he does is he replaces this rod with another massive rod, okay, whose mass is m kg. Initially, it did not have any mass. Now you're replacing it with this. In that case, how does the angular acceleration differ? Now, the student response given here is that he said, anyway, see, when we say that the particle, when the system is rotating about the center here, then what happens is, now this rotates like this rotates like this. So it doesn't mean, okay, what is the mass of the rod? Because the pivot is at the center. The entire mass of the rod, whether it is 1 kg, 2 kg, 10 kg, whatever it is now going to act here, which means the mass of the rod is going to act here and the tension or the normal force is now going to act over here. So normal force balances the mg and hence it does not have any effect on the angular rotation. Okay, this is what it does. And finally, he finds out what is the angular rotation, the angular acceleration. He takes it up as 2mg multiplied by this distance, perpendicular distance, right? 2mg multiplied by this perpendicular distance. Since the length of the rod is already given as 1 meter over here. So he puts it as a 1 by 2 the whole square. So, I'm sorry, this is 2mg into 1 by, I think I made a mistake, 2mg into 1 by 2. What he has done is, he does something like this. This is my force multiplied by the perpendicular distance, which should be 1 by 2 here. And this should also be 1 by 2. While typing, I think I made a mistake over here. So this should be 2mg. So thus you will have, okay, this equation is wrong. Please ignore this. Okay. So you will have, I'm calculating this also here. So you will have 2mg multiplied by half. Okay. If this is going in this direction, I'll say this is positive, while this is now going in this direction. So now the torque here due to this one would be in this direction. The torque due to this will be opposite to this one. So it will be mg over here. So therefore minus mg. Why minus mg? The reason is because torque is opposite. Minus mg into half. Minus mg into half. How did I consider torque? Torque is nothing but force multiplied by distance. Okay. Force multiplied by distance. Which distance? Perpendicular distance from the pivoted center. So here the perpendicular distance is half and here it is minus plus half. But the force here is now in this direction, the force here is in this direction. Okay, so as a result of it, you say anti-clockwise, this is your anti-clockwise. Anti-clockwise torque is positive, clockwise torque is negative. Okay, based on this, I have written as 2 mg into half minus mg into half. What is this now? This is nothing but the net force, net torque, F cross R. That's what we have done. Okay, we have taken two forces, two distances. We have got this. Now this should be equal to I into alpha. Okay, moment of inertia multiplied by R, alpha, angular acceleration, because this is nothing but your torque. Okay, so therefore, now what is moment of inertia? Moment of inertia of this one will now be equal to 2 mg into R square, which is 1 by 4. Okay, plus what is the moment of inertia of this one? This should be mg, sorry, not 2m, not mg, 2m into 1 by 4. Yeah, I'm making lots of mistake. Okay, 2m into 1 by 4 plus m into 1 by 4. These are the moment of inertia into alpha, Why same alpha? This is your I1 into alpha plus I2 into alpha. Why same alpha? Because when this starts rotating, this will also start rotating, right? So as a result of it, I can write like this. Okay, and thus I get this expression here. Okay, so now what do I have here? So 2m into 1 by alpha plus m into 1 by alpha should now be equal to 3m by 4 into alpha. Now what is here? You have 2mg minus mg divided by 2. Okay, 2mg minus mg should be mg. So mg into half. mg into half. This is what we get. So 2 ones are, 2 twos are, and this m and m also goes away. This implies alpha should now be equal to, this 2 goes upwards, 3 comes downwards. This will be 2g by 3. Okay, so alpha should be equal to 2g by 3. This is what you should get. Okay, so that's now you see, I did not use the mass of the rod. Even if I get a mass of a rod here, it doesn't play over here anyway here. Because why? The reason is because this alpha becomes 0 here, right? Alpha becomes 0. So therefore, as a result of it, I need not count it. That's what he has done. Okay, and then hence he said, okay, if I use the mass of the rod also here, I will get I of the rod about the center, okay, which is at the center of mass, and then alpha, since the rod is not rotating, so therefore alpha should be equal to 0. Center of mass is not rotating, so rod is rotating, sorry, center of mass is not rotating, and hence alpha should be 0, and hence it does not make any effect. The mass of the rod is 1 kg, 10 kg, 200 kg, whatever it is, it will have no effect on alpha. Okay, very simple. So this is what is got. Now, this answer is incorrect. Why is it incorrect? Because though the rod does not rotate, but still the moment of inertia will be there for it, right? So it is something like, if you have a lighter rod, you can easily pull it like this. If you have a much massive rod, now this mass of the rod also acts on it. So it's not so easy to pull this across. Very difficult, right? Okay, you would have experienced this. Say, for example, when you sit in a seesaw, okay, so when you sit in a seesaw, so if the mass of this seesaw also plays an important role here. So as a result of this, this mass really counts. So which he has ignored it. Okay. So whenever we talk about angular acceleration of a system, then the mass of the rod really plays a role because there's a moment of inertia associated with it. What is moment of inertia? What is inertia? Laziness of an object. If something is bulkier, then definitely that laziness will be larger, right? So we need to look at that. So let us look at the correct solution. Now, let us redo it once again. So you have 2 mg once again here, half meter. mg is acting here. Now we know summation of f into r, f cross r, will now be equal to the net torque tau, which should now be equal to 2 mg into half minus mg into half. No issues. This is correct. Okay, which should now be equal to mg divided by 2, mg into half. Now this tau is also equal to I alpha. What is I? The total moment of inertia of the system, which should now be equal to I1 plus I2 plus I3 into alpha. Now what is I1? I1 is nothing but the moment of inertia of this particle, okay, above the pivoted point, which should now be 2m into 1 by 4, mr square, by mr square, plus what is the moment of inertia of this particle? Plus m into r square, which is 1 by 2, plus what is the moment of inertia of this rod? Moment of inertia of this rod is nothing but ml square divided by 12. You would have seen this in your moment of inertia concept. I am not going to teach that one here. M into L square. What is L square? 1 square. 1 square divided by 12. What is 12? Okay, 12 is a constant. Whole thing multiplied by alpha. Okay. So what do you get here? You get this as mg by 2. And here this should be 2m by into 1 by 4 plus 2m into, so I'll cancel this also. Are we doing it correctly? Just a minute. M into 1 by 2 whole square, right? This should also be 1 by 4. Okay. So now we have 2m, sorry, I have already cancelled this. M into half, I'll write it down if you want. M into half plus 1 by 4 plus 1 by 12 into alpha. Here I have mg by 2. M goes away here. Now what happens here? We have 1 by 2 plus 1 by 4 plus 1 by 12. How much will this be? Let us take 12 as a LCM. 2 6 are 12, 4 3s are 12, 12 1s are 12 into alpha. Right? Now what do we have on the left hand side? G by 2. G by 2 is equal to 6 plus 3, 9 plus 1, 10. 10 by 12 into alpha. 2 1s are, 2 6 are. Now 2 5s are, 2 3s are. Thus we have alpha is equal to 3g by 5. So this is your final answer. Okay. Compare it with the previous expression. The previous expression said the value of it was 2g by 3. I hope you have understood this particular example, like how do we arrive at the angular acceleration, or what is the role of angular acceleration, and how do you relate it to moment of inertia. Okay. So whenever you have moment of inertia, that plays an important role in determining the angular acceleration. Thank you friends for watching this video until the end. So if you really like this video, do share and subscribe to my channel for further updates. Thank you.